You've just cloned Android Oreo. You type make and the build instantly dies. Here is what actually happens under the hood when you see that highlighted error. Your brand new Ubuntu machine is paradoxically too new for AOSP, creating a fundamental conflict. This isn't a bug, it's a deliberate security and compatibility constraint. So how do we fix a problem caused by having better tools? It starts by understanding the bytecode. The entire Android framework is built on Java, but it's not the Java you run on a server. The key is this highlighted phrase. The bytecode from the Java compiler must fit perfectly into the Android runtime for that specific OS version. Using a modern JDK to compile old code generates bytecode that the older runtime, whether it was Dalvik or ART, simply cannot understand. It's a rejection at the most fundamental level. This strict coupling is the root cause of the build failure. Think about the highlighted analogy here, a new car key in an old ignition. It's a perfect metaphor. The physical shape of the key has changed. No matter how hard you try, it will not turn the lock. In the same way, the shape of the bytecode produced by Java 11 is fundamentally different from what Android 8.0's runtime was built to execute. The build system fails fast because it knows the output would be completely unusable. So how do you provide the right key? You have to use the exact JDK the original platform engineers used. Notice the table on screen. For the earliest Android versions like Cupcake through Froyo, the build system is hard-coded to expect Java 5. For Gingerbread up through KitKat, that requirement was bumped to Java 6. You cannot deviate from this. The build scripts will check and fail if the version is wrong. This was the law of the land for years. As the platform evolved, so did the toolchain. For Lollipop and Marshmallow, we moved to Java 7. Then, for Nougat and Oreo, as you can see highlighted, the requirement became OpenJDK 8. This shift to OpenJDK was critical. Most people trip over this because they try to install the proprietary Oracle JDK. But the build system has dependencies and assumptions baked in that rely exclusively on OpenJDK. Using the wrong JDK is a common source of very strange, hard to debug compiler errors. Here is what actually happens under the hood when you set up a legacy environment. You don't just install the old JDK, you have to explicitly tell your shell where to find it. Look at these commands. First, you use apt to install the specific OpenJDK 8 package. Then, you must export these environment variables, Java home and path, to point directly at that installation. This overrides your system's default Java, forcing the make command to use the correct older compiler. The trick that took me 3 years to learn is to never ever mix JDKs. The most common mistake, highlighted right here, is using the Oracle JDK. AOSP is built and tested exclusively with OpenJDK. The build system can fail in very non-obvious ways if it finds Oracle's binaries. It might seem like they should be compatible, but small differences in the toolchain can cause massive problems down the line. Stick to OpenJDK always. This constant environment management was a huge problem for Google. How do you ensure 10,000 engineers get the exact same build result? The "it works on my machine" issue, which you see highlighted, is a nightmare for platform integrity. We needed a way to guarantee that the bytecode produced in Mountain View was bit for bit identical to the bytecode produced by an engineer in Zurich. Relying on individual host machine setups made that impossible. The goal is a mathematical guarantee of a reproducible build. Look at the highlighted phrase. The output must be perfectly identical every single time. If a developer has a slightly different patch version of OpenJDK 8 installed, it could introduce subtle changes in the compiled output. For a platform as complex as Android, these tiny deviations can lead to security vulnerabilities or highs and bugs that are impossible to track down. The host environment had to be removed from the equation. So what was the solution Google engineered? A hermetic build system. Instead of asking you to install the right tools, modern AOSP, starting with Android 9, ships with its own locked toolbox right inside the source tree. It completely ignores whatever Java version you have installed on your host machine. This was a massive shift in philosophy from bring your own tools to use our certified version locked tools to guarantee consistency for everyone. This diagram on screen shows the change perfectly. The legacy build on the left shows an arrow going from the make command out to the host Java. This signifies that the build process had to leave the source tree and depend entirely on the host operating system's configuration. This external dependency was the primary source of all the versioning chaos we faced for nearly a decade. Now look at the modern build flow. The N command is intercepted. Instead of looking at the host OS, the build system is rerouted internally to that path you see highlighted, /prebuilds/JDK. Your host operating system is completely bypassed. The AOSP source tree becomes a self-contained universe, providing its own compiler. This guarantees that every single person building Android 14 uses the exact same JDK binary down to the last byte. You can verify this yourself. You don't need to guess which version is being used. Just navigate into the prebuilds directory inside the AOSP source tree and execute the Java binary directly with the version flag, just like the highlighted command shows. This will print the exact custom OpenJDK version that Google has certified and shipped for building that specific version of Android. No more guesswork. Here's a final tip that trips up even experienced engineers. On modern branches, running sudo apt upgrade and updating your host Java does absolutely nothing for your AOSP build. The AOSP toolchain, as we've established, explicitly ignores host variables and paths. You could have no JDK installed on your Ubuntu host at all, and a modern AOSP branch will still compile perfectly because it brings its own. Now that the tools are self-contained, we need an engine to manage the complexity of compiling millions of files.
Enjoyed the video? Hit like and subscribe for your regular dose of AOSP customization. Thanks for watching. See you in the next one.